tu veux.
Bah, plutôt, ouais, tu regardes les stats, où est-ce qu'ils sont, tu vois.
Où est-ce que je les tape?
Donc là, je trouve que
Oui, c'est tout.
l'ensemble
C'est un
de
peu
ce
du
voilà.
bénévolat, quoi. En fait, c'est un peu une ONG que j'essaie de mettre à
C'est un peu pensé. C'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est un peu une ONG que j'essaie de mettre à
c'est un peu pensé. C'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça.
Acheter des chartes.
Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est un peu une ONG que j'essaie de mettre à
c'est un peu pensé. C'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est un peu une ONG que j'essaie de mettre à
c'est un peu pensé. C'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est un peu une ONG que j'essaie de mettre
c'est un peu pensé. C'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est un peu une ONG que j'essaie de mettre
c'est un peu pensé. C'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est
c'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout.
L'ensemble
C'est un peu du bénévolat, quoi. En fait, c'est
c'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout. C'est un peu du bénévolat, quoi. En fait, c'est
c'est qu'une ONG, le but, c'est quand même la tradition démocratique.
Oui, mais l'ONG, elle est pas ça. Elle est plus
Acheter des chartes.
Oui, c'est tout. C'est un peu du bénévolat, quoi. En fait, c'est
Welcome to the third day already of our and as yesterday, a quick recap and lots of greetings again from our host.
Recording in progress.
This time, welcome to the third day already of our and as yesterday, a quick recap and lots of greetings again from our host.
Recording in progress.
This time, welcome to the third day already of our and as yesterday, a quick recap and lots of greetings again from our host.
Recording in progress.
This time, welcome to the third day already of our and as yesterday, a quick recap and lots of greetings again from our host.
Recording in progress.
This time, welcome to the third day already of our
Recording in progress.
This time, welcome to the third day already of our
Recording in progress. 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 Recording in progress.
might cause delays or difficulties in convergence. Different hardware, software, and settings also might cause delays or difficulties in convergence. Different hardware, software, and settings also might cause delays or difficulties in convergence. And software and settings also might cause delays or difficulties in which is perfect for all use cases. Interesting here is also the personalization, federated personalization, where essentially you can keep only some of the layers of the network you have trained, and then use, let's say, some local knowledge to train the final layers and make your network more personalized. Because as we said, the global model that comes from the common knowledge of everyone might not be so close to your use cases, so you may want to add some extra personalization aspects there. Now, regarding the framework, for us, we will work with the Flower Federated Learning Framework. Our challenge is also supported by this framework. Some key aspects, Sevi will mention more things about that, but just some key aspects here that were very attractive to us was the fact that you can handle heterogeneity. So you can have any ML framework like PyTorch or TensorFlow. It covers all different frameworks. And then also it's, I think it's also language agnostic. Besides Python, you can also use R, I think. I'm not sure about that, I have to check. But it's very supportive for different equipment. And you can have synchronous or asynchronous aggregation of your models. There is lots of customizability in terms of how you select clients to participate in each epoch. So you may not want to use all your clients' models. You might want to specifically select some. And most importantly is the scalability factor. It's very easy to go from just a few clients to many thousands of clients, and as they show in their research, you don't compromise the model performance. And also they have some solutions for the performance and the bandwidth usage. So now let's move to the security challenges a little bit. And first of all, let's talk about some vulnerabilities here. So as we said before, you don't expose your data anymore, but the models are data-driven. They are created from data, and some information might be, let's say, reverse engineered from the models. So also there are other attacks like the model poisoning attack, where some malicious participant might manipulate the gradients and send a local model which is trained with, which is not actually according to the rest of the distribution. Attackers can also, if they can get to the model, they can analyze and infer sensitive information about the data that the model was trained. This is the reverse engineering kind of attack. And we have also compromised participants who can send faulty updates. and this can cause problems for the model to diverge or a difficulty to converge into a single global model. The model inversion is more like the reverse engineering problem, so we'll not go into that. Oops. We have adversarial attacks where adversaries can cause the model to misbehave in some certain conditions. So in this case, your model is okay, is like reliable for some for some examples, but might be some examples for which it will have some adversarial behavior. And then in Sybil attacks, you have multiple fake participants who are essentially doing something like a DDoS attack to the model training, and or they cause some bias so that the models are predicting some specific predictions, and they're not, like, let's say, equally distributed across all classes, not balanced. So there are several mitigations for that. Of course, there are many more attacks like that, and this is just a sample. But also on the mitigation aspects, there's lots of research. Differential privacy, where the model weights are a little bit changed with some noise, so that even if someone, if a bad actor manages to get access to the model during transmission, they are not able to, it's not easy to infer the actual parameters. Then you have secure aggregation, where takes place beforehand, and the participants or the global, the server is aware of the encryption factor, and so anyone else who is getting access to that. Oops. Sorry, can you please pop-ups? Sorry for that. So yes, I will not go into detail about all these mitigations, but for example, anomaly detection also is a nice use case where you can essentially do anomaly detection on the model weights, see if something is changing from the usual pattern. And homomorphic encryption is very important as well. Again, it works with encrypting the computations. So instead of aggregating the decrypted weights, you aggregate it and you do all the computations on the encrypted weights. These are challenging approaches, but it's important to work in this direction, because even if you are more safe, since data is not transmitted, the model is still important, and research has shown that some knowledge can be extracted from the model weights. Now some emerging trends and future directions. We have the personalized federated learning. Leonardo also has presented something on that. This is a very interesting direction. So you can, as I said before, I mentioned a little bit about that. You can locally fine-tune the global model to make it more adequate for your own data distribution. So other trends focus on the model compression and adaptive client participation to make more efficient the communication exchange. We have incentive mechanism and fairness. This is something also very interesting for us. How can you encourage participants to work more efficiently and report honestly on the results and the evaluations? We have different clients that contribute unequally. This might cause also bias, so we want to have everyone be participatory. And then finally, it's the decentralized learning. This is something that we are actively work also in the context of CyberSecDOM. So in the decentralized federated learning paradigm, we avoid having a central server. So as we can see here, in the centralized approach, you have the central server. That's what we discussed so far, and everyone sends their model there. In the decentralized approach, you skip completely the central server, and you have peer-to-peer communications among nodes. They exchange their data directly, their models directly. This is an area that receives much interest now. And essentially, the elimination of a central server avoids to having a single point of failure, which is very important. And also the bottlenecks. You enhance privacy since not everyone shares with towards a central location. And also you have better scalability, increased fault tolerance, and lower communication cost. So this is something very interesting for us. We were working on that actively. And now some use cases. So this was our first, the teaching project was our first attempt to work on these aspects. We're more on the side of the modeling, but the use case there was with ABL and Talis. There was an avionics and an automotive use case where we had to do human state biosignals training for stress prediction. So this was sensitive data. We needed, it was a good paradigm for federated learning because we didn't want to share this kind of personalized data. And then for Edge AI, we use it for air quality forecasting. So we have many RSPUs. RSPUs, these perception units, are basically based on JSONs, and the models are trained there with many sensor data for air quality, but also for hardware performance of JSONs itself. And we use local models there, and the streaming architecture to enable it, again with the Flower framework. We have also another new project now, news, with different use cases. The one use case is the connected vehicles. Again, an automotive kind of scenario, energy prediction, and then scientific data, where you have like organizations who are doing scientific analysis or like medical data and so on. And of course, these are sensitive data, and you want to enable data scientists to work together on that, but without having access to directly access to the data. Something challenging for data scientists, but is a paradigm that is of interest. And finally, CyberSecDOM. We talked a lot about that yesterday. This is a distributed architecture. So here we have big organizations like telecommunications companies, like OT in Greece, and the Greek airport, Eleftherios Venizelos. They have multiple security tools, and these tools are trained with AI-based models. And we want to be able to get knowledge from one organization. For example, let's say one organization OT might have lots of cybersecurity data on DDoS attack, and a new organization that is now entering CyberSecDOM, they don't have such use cases. They have not collected such examples. They can benefit from the AI knowledge of the first organization and combine it with perhaps another attack they had on their own collected data. This is a use case that we also need to work on the incentives. So yes, that's it. Sorry for going a little bit fast. I hope I just gave an overview, and if you want to go in further depth in some of these areas, we can discuss it and we can communicate also after the summer school. If you have any questions now, we can answer it, or we can move to the FL challenge. And this is the team from ITML. We have worked on it. And I will hand it to Sevi to let you know about that.
Thank you.
My name is Sevi Politi, and I am a machine learning engineer at ITML in Athens. So I will present to you your challenge for today that we have prepared, and this is federated anomaly detection with Flower framework. No. Okay. So I will make an introduction to the use case that you will have to deal with today. Some prerequisites that you should have on your machines. Then I will say a few words about the frameworks and the tools that we have used and you will also use today. Then I will make a short demo about MLflow. Do you know MLflow? No? Okay, it's okay. And then I will give you a walk through the challenge guidelines we have prepared for you. It's very analytical, so it will be easy for you to do the steps. Okay, so a few words about the use case. We use the NBA IoT dataset, which focuses on IoT devices with benign and malicious behavior. These features are related to network traffic data and device activity. We use this dataset because it's suitable for anomaly detection problem in the context of cybersecurity. Since the dataset was labeled, we used the binary classification method to classify traffic as benign or malicious. For this challenge, we can have up to 4 clients, and we have assigned one device to each client. These devices are cameras, thermostats, devices like this. So your challenge will be to improve the performance of the global model while preserving privacy. The evaluation metrics that we will use to evaluate your global models will be accuracy, recall, specificity, and F1 score. The two main prerequisites that you need to have is Docker and Git. It will be really useful if you have an IDE on your computer, and Python 3.10 is completely optional. Okay, so now a short introduction to the Flower framework. Flower is open source and is used for building federated learning systems. Its key features is usability, scalability, versatile deployment, and it's easy to move from research to production. And additional Flower is FL framework agnostic. You can use it with TensorFlow, PyTorch, Keras, and it's also platform independent. You can use it on Windows, Linux, Mac. Okay, so how Flower works, Mina also described it earlier. During one federated learning round, the server initializes the global model and sends it to the participant clients. Then the clients will perform training on their global data, on their local data, sorry, and they will send back the model updates to the server. Then the server will aggregate these updates and will send back the global model to the clients to train their data again. For those who don't know about Docker, Docker is an open source platform that automates the deployment of applications in containers. We use Docker for consistency. It's very helpful for deployment and also for scalability, so that you will be able to run one or more clients. Okay, now about MLflow. MLflow is also open source, and it is used to manage the life cycle. We use MLflow to track experiments, to log data like metrics and other useful information about the training of a model. And then another feature that MLflow has is registering models. So this will be very useful for you to register the best global model that you will end up with. Okay, so now I will also show you a few stuff about MLflow. Just give me a moment. I would like to change screen. Okay. Okay. Great, thanks. Okay, so this is the UI of MLflow. On this side, you can see the experiments. Each experiment can have multiple runs. So now, as you can see here, these are the runs. If we take those three, you can see that they have the same ID here, it's timestamps. So it's the results from the server and two clients. These three are from the same federated learning simulation. So this is one FL simulation and this is another one. If you go further here, you can see some metrics. You can also choose columns to see whatever you need here and compare the models, either the client models or the global models. Also there is, just a moment. Okay, so you can also choose, let's say, this from this FL simulation and maybe client one from this simulation, and also compare them. You will see some charts and parameters next to each other, compare to see the differences. And now let's see how you can register a model to MLflow. So I chose a client. Something else that I would like you to know is that the clients of the same FL simulation have the same global model. So if you need to register a model, you can choose either whichever client you want to register the model. So I chose this client. Let's say that he has the best model of the FL simulation. You click register model, and then you will add the model name. You will create a new model. Let's name it example team, as it's the name of the experiment. Okay. And now we go here to models. You can see the model that I just registered. This is under version 1. If at some point you need to register another model, you can select the one that you have already registered, the name, and then it will be registered under a new version. So now, do you have any questions about ITML flow? Okay. So now let's go through the guidelines. Okay. So first of all, you have some directions on how you can set up the repository with the code on your machine. Then you will have to configure some parameters for so that you will be able to connect to MLflow and log stuff to your experiment. And then you will have some guidelines for you to be able to test the first FL simulation with Docker and make sure that everything works fine on your machine. Then you will see some guidelines on how you can start the challenge and what parameters you can configure to improve your model. If there are words or metrics and stuff that you don't know, we have added the definition. So, for example, here, the number of participating clients. If you click, there's a link to the definition. There are also guidelines on how you can register your model. And then what are the steps for you when the challenge is over? This section is completely optional. You don't have to do it unless you want to deep dive in the code. And yeah, that's all from me. I think that we can start the challenge. Do you have any questions before we start? Yes? I will share it to you right now. Yeah. Yeah, yeah. Which of you have Docker on your machines? Perfect. Okay, so it would be nice if you have teams with people that have Docker. Yeah. I also sent you the email with all the files that you need. Yes? Yeah, sure. Yeah. Mm, let's see.
You also have it? Okay, perfect. So how would you like to go? Each one on its own or you're together? Okay, perfect.
We are also a team.
Perfect.
Thank you. Once again, a new account. Yeah, no worries. It's the email. It's in the email.
Yeah, unless you can put someone else that already has
Yeah, sure. But not here.
yeah, no problem. Okay.
You can go on your own as well if you want to go.
Yeah, me too.
Yeah, I mean, I can give you a second number. So the idea with the numbers is that it's a team. Every number is a team, and they can take part at the final leaderboard when we receive the results of the best results. So I can give you another team here, and if you decide you can just keep it and work with one
I can
person.
do my own team.
Perfect. Maybe I mean, the challenge is also created in such a way so that it can accommodate different levels of expertise. And it might seem a little bit simple to some of you, but the idea is like to see how the whole thing works. If you want to deep dive, as Sevi said, of course there is room to try more exotic stuff. And two things here.
With her.
Jetzt und später.
Okay, I'll give you one more. You decide. You can buy the one or this one has the one, right?
She brings her office.
Did you receive the email? Okay, so
She gives the team.
yeah, that's
Okay.
Are you participating? And are you going to be with something? You have everything installed, Docker and
No, not the micro-git.
oh, sorry. I mean, Git and Docker. So maybe, let's just do no. Do you have many participants in the line? Ora tu come se
Oh, you got the link? Never seen anything from anywhere. Oh, yeah.
Yes.
That's an Australia. So now that you have teamed up, there is an Excel in the link that I shared with you.